This video covers an exemplar response to the open-ended response question from our last science quiz. The question states, Sydney and Valparaiso are the same distance from the equator, and both are near the ocean. Is Valparaiso warmer, colder, or the same temperature as Sydney? Explain why as completely as you can. In class, we've talked about a few things that affect the temperature of a given location. The first is the distance from the equator. We can see in this image that both locations have a similar distance away from the equator. And so that's not what's going to differentiate their temperature. Some students may have accidentally responded that their temperatures are the same because they're the same distance from the equator. However, this ignores the next concept that we learned this report period, which is about how ocean currents affect temperature. When we look at the ocean currents as they move throughout the image, we can see that there is one current heading just underneath the equator, west. In class, we've discussed how when currents hit continents or land formations, they can start to move. In this case, as the current hits Sydney, we see that it would curve downwards. The reason this is the case is because the direction that the arrows are pointing and because of where it runs into the land formation. In contrast, near Valparaiso, we see that we have an eastward current. When this eastward current runs into the land formation, it will start to move upwards. As the current curves north, it will pass the land formation. The reason why these two currents matter is because the water is a different temperature. The ocean current that's moving downward past Sydney is warm because it's close to the equator. That means Sydney is going to experience a warm ocean current because the water moving past the land formation, in this case the coastline, is warm. More specifically, we've talked about how there is more energy that is transferred to the ocean water at the equator. This means that the ocean surface has extra energy that it carries from the equator that it transfers to the air in Sydney. In other words, at Sydney, energy is being transferred from the warm ocean into the cooler air. In contrast, in Valparaiso, the ocean current is much colder because it's farther from the equator, which means the surface of the ocean receives less energy from the sun. Here, the energy transfer is occurring in the opposite direction. The air is transferring energy to the ocean water because the air is cooler than the ocean current that's moving past the coastline. Because very little energy is transferred to the surface at the South Pole, where this blue current is coming from, the water is cooler than the air. That is how students should have explained that Sydney is warmer than Valparaiso. In class, I asked for at least 3 full sentences to explain this phenomenon. It should have included information about the ocean currents, the energy transfer, and the location of both cities. Let's write an exemplar response. First, we want to restate the question. We'll write, Sydney is warmer than Valparaiso. So right off the bat, we've given our answer to the question. Then, we'll need our justification to include why. We just talked about how the ocean current moving past Sydney originates at the equator, meaning it's coming from the equator. And we can simply say, which receives lots of energy from the sun and is warm. So we know that we have a warm current that's coming past Sydney. That means energy is transferring from the warm water to the cooler air. Now, we know that at the other location, Valparaiso, the opposite is happening. And the reason why the opposite is happening is because a cooler current from the South Pole is passing the coast. Which means instead of energy transferring from the ocean to the air, we have energy transferring from the air to the ocean. I'm going to write here, energy transfers from the air to the ocean, which cools the air temperature. And that's the difference between these two locations. Student responses should have included a conversation about energy transfer and the way that ocean currents are moving. Another thing that we could have added is that these ocean currents are being created by prevailing winds, meaning winds that are moving in one singular direction. Notice that an exemplar response completely answers the question with all of the key concepts we've covered in class during our last unit. Students also had an opportunity to practice rewriting their open-ended response in class, and there will be an opportunity to retake the open-ended response when we come back to school after the weekend. So Monday, there will be a retake.